Et si la découverte la plus importante de l'astronomie n'était pas une simple roche spatiale, mais quelque chose de bien plus extraordinaire? Les récentes observations de 3i ont révélé des caractéristiques si inhabituelles que certains scientifiques remettent en question tout ce que nous pensions savoir sur les visiteurs interstellaires. Le comportement de ce vagabond cosmique remet en question notre compréhension de la nature de l'univers. Découverte et détection initiale. Quelles sont les chances d'apercevoir une aiguille cosmique dans l'infinie botte de foin de l'espace? Le 1er juillet 2025, le télescope Atlas de Rio Hurtado, au Chili, a réussi cet exploit en détectant un objet mobile de faible luminosité initialement catalogué à 11 PL3L. Cette découverte a marqué un moment historique. Les astronomes ont réalisé qu'ils avaient trouvé le troisième objet interstellaire confirmé jamais détecté par l'humanité. Après les découvertes révolutionnaires de Oumuamua en 2017 et de Borisov en 2019, ce nouveau visiteur a été officiellement désigné 3i et classé cométaire C 2025N1. Cependant, ce qui rend cette détection particulièrement intrigante, c'est que malgré sa luminosité finale, 3i est resté invisible lors de sa précédente détection en raison de son angle d'observation difficile à son approche depuis le Soleil. Cette découverte tardive, bien que l'objet soit entré dans notre système solaire quelques mois plus tôt, soulève des questions sur le nombre d'autres visiteurs interstellaires qui auraient pu passer inaperçus. La trajectoire et le timing de l'objet suggèrent qu'il a peut-être été délibérément positionné pour éviter une détection précoce, une caractéristique qui a retenu l'attention des astronomes du monde entier. Quelques jours après confirmation, les observatoires du monde entier ont commencé à suivre ce mystérieux visiteur, mais son comportement allait bientôt remettre en question les explications conventionnelles concernant les objets interstellaires. Caractéristiques orbitales extraordinaires. Comment un objet interstellaire peut-il suivre une trajectoire aussi parfaitement conçue pour l'étude de notre système solaire? 3i possède des caractéristiques orbitales qui défient les lois de la probabilité et remettent en question notre compréhension du mouvement cosmique aléatoire. L'objet suit une orbite hyperbolique avec une excentricité extrême de 6,14, ce qui en fait la trajectoire la plus hyperbolique jamais enregistrée pour un objet interstellaire confirmé. Filant dans l'espace à une vitesse d'approche de 58 km par seconde, il détient le record du visiteur interstellaire le plus rapide jamais détecté par l'humanité. Ce qui rend ces caractéristiques vraiment extraordinaires, c'est l'alignement de la trajectoire de l'objet. Sa trajectoire se situe presque parfaitement dans le plan de l'écliptique, les astronomes n'ayant calculé qu'une probabilité de 0,2% qu'un tel alignement se produise par hasard. Ce positionnement précis permet à 3i d'obtenir des angles de vue optimaux sur toutes les planètes majeures de notre système solaire, s'apparentant à un itinéraire d'observation soigneusement planifié plutôt qu'à la trajectoire chaotique attendue d'un objet éjecté naturellement. La précision mathématique de cette trajectoire a incité certains chercheurs à se demander si les interactions gravitationnelles naturelles pouvaient à elles seules produire une configuration orbitale aussi improbable. Contrairement aux objets interstellaires classiques qui pénètrent notre système solaire par des directions aléatoires, 3i semble suivre une trajectoire spécifiquement conçue pour une observation planétaire complète, ce qui soulève de profondes questions sur la véritable nature de cet énigmatique visiteur venu des profondeurs de l'espace interstellaire. Rencontre planétaire suspecte. Quelles sont les chances qu'un visiteur venu de l'espace interstellaire croise chaque planète majeure de notre système solaire? La trajectoire de 3i présente des improbabilités astronomiques qui remettent en cause les explications conventionnelles concernant les objets naturels. Des calculs révèlent que ce mystérieux visiteur passera exceptionnellement près de Vénus, Mars et Jupiter, les astronomes estimant à seulement 0,005% la probabilité que de telles rencontres planétaires se produisent par hasard. Plus suspect encore est le moment de son approche au plus près du Soleil, qui se produit précisément au moment où la position de la Terre bloque les possibilités d'observation optimale, un événement dont la probabilité d'occurrence aléatoire n'est que de 7%. Ce timing stratégique garantit que 3i reste partiellement caché pendant son approche solaire la plus vulnérable, au moment où l'augmentation du réchauffement solaire révélerait le plus de détails sur sa composition et sa structure interne. La trajectoire de l'objet ressemble à celle que les planificateurs de missions concevraient pour un vaisseau spatial de reconnaissance effectuant une étude approfondie de notre système solaire. Chaque rencontre planétaire offre un positionnement optimal pour l'étude des effets gravitationnels, de la composition atmosphérique et des caractéristiques planétaires, précieux pour toute civilisation avancée cherchant à comprendre notre environnement cosmique. La précision mathématique requise pour obtenir une telle trajectoire par des processus d'éjection naturelle semble quasiment impossible. ce qui conduit certains chercheurs à suggérer que 3i pourrait représenter un phénomène bien plus sophistiqué qu'une simple comète interstellaire dérivant au hasard dans la galaxie. Propriétés physiques et anomalies. Comment un objet peut-il être à la fois incroyablement ancien et étonnamment bien préservé ? 3i présente un paradoxe fascinant dans ses caractéristiques physiques, qui remet en question notre compréhension de l'évolution des objets interstellaires. Avec un diamètre estimé entre 1 et 12 km, il est nettement plus grand que les précédents visiteurs interstellaires, ce qui en fait l'objet confirmé le plus important provenant d'au-delà de notre système solaire. Les estimations d'âge suggèrent que ce vagabond cosmique a plus de 7 milliards d'années, précédant de plusieurs milliards d'années la formation de notre système solaire. Malgré ses origines anciennes, 3i s'est distingué comme l'objet interstellaire le plus brillant jamais observé, atteignant des magnitudes permettant une étude détaillée avec des télescopes terrestres. L'objet présente une période de rotation de 29 heures avec des variations de luminosité remarquablement minimes, suggérant une forme inhabituellement sphérique ou allongée qui maintient une surface transversale constante pendant sa rotation. Ce qui intrigue le plus les astronomes est de savoir comment un objet d'un âge aussi avancé a pu conserver son intégrité structurelle pendant des milliards d'années de voyages interstellaires, survivant aux impacts de poussière cosmique, aux bombardements radiatifs et aux perturbations gravitationnelles dues au passage des étoiles. La préservation d'un artefact aussi ancien soulève des questions sur sa composition et sa structure interne. La plupart des objets naturels de cet âge devraient présenter une altération et une fragmentation importantes, mais 3i apparaît remarquablement intact, ce qui conduit certains chercheurs à spéculer sur des propriétés matérielles ou des méthodes de construction inhabituelles qui pourraient expliquer son extraordinaire longévité. Caractéristiques de type comète vs. Comportement anormal. Pourquoi 3i se comporte-t-elle à la fois comme une comète typique et présente-t-elle des caractéristiques contradictoires avec la physique cométaire ? Ce visiteur interstellaire présente un mélange déroutant de comportements attendus et anormaux qui laisse perplexes les astronomes. D'un côté, l'objet présente des caractéristiques cométaires évidentes, notamment une faible coma et une courte queue de 3 secondes d'arc, indiquant un dégazage actif lorsque le rayonnement solaire réchauffe sa surface. Les observations spectroscopiques confirment la présence de vapeur d'eau et de particules de poussière éjectées du noyau, créant l'aspect flou familier associé aux comètes s'approchant du Soleil. Cependant, plusieurs caractéristiques s'écartent significativement du comportement cométaire typique et remettent en question les connaissances conventionnelles. Contrairement aux comètes normales qui développent de longues queues fluides à l'approche du Soleil, 3i conserve une apparence remarquablement compacte et dense malgré sa proximité avec notre étoile. Le développement spectaculaire de la queue, attendu lors de l'approche du Soleil, semble mystérieusement absent ou significativement réduit. De plus, les schémas de dégazage de l'objet ne suivent pas les modèles prévisibles utilisés pour les comètes du système solaire. L'activité débute beaucoup plus tôt et suit des schémas d'intensité inhabituels. La combinaison de caractéristiques cométaires reconnaissables et de comportements anormaux crée un casse-tête scientifique difficile à catégoriser. Certains chercheurs suggèrent que ces contradictions pourraient indiquer une origine artificielle conçue pour imiter l'activité cométaire naturelle tout en conservant des avantages structurels empêchant la fragmentation typique observée chez les comètes naturelles lors de rencontres solaires rapprochées. Débat scientifique, naturel contre artificiel. L'humanité serait-elle le premier objet artificiel confirmé provenant d'une autre civilisation ? Cette question a suscité un débat intense au sein de la communauté astronomique, le professeur Avi Loeb de l'université Harvard menant des discussions controversées sur les origines artificielles potentielles de 3i. Loeb souligne la trajectoire statistiquement improbable, la précision du moment de la rencontre planétaire et les caractéristiques physiques anormales comme autant de preuves que cet objet pourrait être le fruit d'une technologie de pointe plutôt que d'une formation naturelle. Ces arguments reposent sur l'impossibilité mathématique de réaliser une trajectoire de reconnaissance aussi parfaitement conçue par éjection gravitationnelle aléatoire depuis un système stellaire lointain. Le positionnement stratégique de l'objet pour une observation planétaire optimale, tout en minimisant les possibilités de détection, suggère une conception intentionnelle plutôt qu'une coïncidence cosmique. Cependant, la majorité de la communauté scientifique s'oppose fermement à ces interprétations, les qualifiant de spéculations irresponsables qui compromettent la recherche astronomique sérieuse. D'éminents planétologues soutiennent que ces caractéristiques inhabituelles peuvent s'expliquer par des processus naturels que nous ne comprenons pas encore totalement, soulignant la dynamique complexe de la formation des systèmes planétaires et des mécanismes d'éjection. Ils soulignent que les affirmations extraordinaires nécessitent des preuves extraordinaires, et que les observations actuelles, bien que déroutantes, ne fournissent pas de preuves suffisantes de construction artificielle. Le débat met en lumière des questions fondamentales sur la manière dont nous interprétons les données anormales et les critères requis pour envisager des explications non naturelles. Cette controverse scientifique illustre les défis que représente l'étude de phénomènes véritablement inédits qui repoussent les limites de notre compréhension actuelle. Les mystères de l'analyse spectrale. Que se passe-t-il lorsque les empreintes chimiques d'un objet contredisent tout ce que nous savons sur la glace cosmique ? L'analyse spectroscopique de 3i Atlas a révélé des divergences déconcertantes qui remettent en question notre compréhension de la composition des objets interstellaires. Si les premières observations ont détecté le spectre attendu de la glace d'eau, une analyse détaillée révèle des anomalies significatives dans les schémas spectraux. Les signaux observés augmentent précisément là où les modèles théoriques de l'eau prévoient qu'ils devraient baisser, créant une énigme scientifique qui pousse les chercheurs à remettre en question leurs hypothèses fondamentales sur la composition des comètes. Ce comportement spectral inhabituel suggère soit des structures de glace inconnues formées dans des conditions interstellaires extrêmes, soit la présence de matériaux exotiques introuvables dans les objets typiques du système solaire. La coloration rougeâtre caractéristique de l'objet ajoute une couche de mystère supplémentaire, rappelant les astéroïdes de la ceinture d'astéroïdes externes plutôt que les couleurs neutres ou bleues typiques des comètes intactes. Les modèles standards ne peuvent expliquer adéquatement cette combinaison de couleurs par les schémas de dégazage observés, suggérant une chimie de surface complexe altérée par des milliards d'années d'exposition au rayonnement cosmique. Pour compliquer encore les choses, la chevelure active entourant le noyau interfère avec les mesures spectroscopiques, rendant difficile la distinction entre les émissions provenant de la surface solide et celles des gaz du nuage environnant. Les tentatives avancées de modélisation informatique pour séparer ces contributions ont donné des résultats contradictoires, certaines analyses suggérant la présence de matériaux qui ne devraient pas exister dans les corps cométaires naturels. Ces mystères spectraux ont incité certains chercheurs à se demander si 3i Atlas pourrait contenir des matériaux artificiels ou représenter un type d'objet totalement inconnu de la science astronomique actuelle. Conséquences de l'hypothèse de la forêt sombre. 3i Atlas pourrait-il constituer la preuve d'une civilisation extraterrestre prudente, selon l'hypothèse théorique de la forêt sombre ? Cette idée controversée suggère que les civilisations avancées restent cachées pour éviter d'être détectées par des voisins potentiellement hostiles, menant des missions de reconnaissance tout en minimisant leur propre exposition. Le comportement de 3i Atlas correspond étrangement à ce cadre théorique, affichant ce qui semble être des caractéristiques délibérément furtives conçues pour éviter d'être détectées dans ces moments les plus vulnérables. La trajectoire de l'objet lui assure de rester partiellement caché derrière le Soleil lors de son approche au plus près, moment où un réchauffement solaire accru révélerait le plus d'informations sur sa structure interne et sa composition. Ce positionnement stratégique permet une étude approfondie de notre système solaire tout en minimisant les possibilités d'observation détaillées par des télescopes terrestres. Le timing et la trajectoire semblent conçus pour une collecte maximale d'informations avec un risque d'exposition minimal, ressemblant à la stratégie d'exploration prudente qu'une civilisation avancée pourrait employer lors de l'exploration d'un système stellaire potentiellement habité. L'hypothèse de la forêt sombre, popularisée par l'auteur chinois de science-fiction Liu Cixin, suggère que les civilisations restent silencieuses car révéler leur localisation invite à la destruction par des voisins plus puissants. Si 3i Atlas représente une telle mission de reconnaissance, son comportement témoigne d'une remarquable sophistication dans l'équilibre entre objectifs scientifiques et instinct de survie. La possibilité que nous assistions à la première rencontre de l'humanité avec une technologie extraterrestre effectuant une étude furtive de notre système solaire soulève de profondes questions sur les protocoles de la civilisation cosmique et sur notre place dans une galaxie potentiellement peuplée mais silencieuse, peuplée d'observateurs cachés. Contexte historique et leçons. La découverte de 3i Atlas a de profondes implications, façonnées par nos expériences antérieures avec les objets interstellaires et les opportunités scientifiques que nous n'avons pas su exploiter pleinement. Le premier visiteur interstellaire, un Oumuamua, a pris les astronomes complètement au dépourvu lorsque Robert Weirich l'a détecté à l'aide du télescope Pan-STAR 1 en 2017. La sortie rapide et inattendue de l'objet de notre système solaire a laissé la communauté scientifique avec plus de mystères que de réponses, notamment concernant son étrange comportement d'accélération qui défiait les explications conventionnelles. Cette opportunité manquée a mis en évidence des lacunes critiques dans nos capacités de réaction rapide pour l'étude des phénomènes cosmiques rares. Le deuxième objet interstellaire, 2i Borisov, découvert par l'astronome amateur Gennady Borisov à son observatoire de Crimée en 2019, a offert une opportunité de rédemption qui a été mieux exploitée, mais qui restait limitée par les technologies disponibles et les limitations de coordination. Mark Norris, de l'Université du Lancashire central, souligne que 3i Atlas représente notre opportunité la plus complète à ce jour pour étudier en profondeur un visiteur interstellaire grâce à une instrumentation avancée et à des stratégies d'observation mondiale coordonnées. Les capacités de détection améliorées des systèmes contemporains d'observation du ciel, combinées à des protocoles de communication internationaux optimisés, ont permis une coordination en temps réel sans précédent entre les centres de recherche du monde entier. Michel Banisté souligne que les enseignements tirés des précédentes rencontres interstellaires ont révolutionné notre approche de l'étude de ces remarquables messagers cosmiques. Observations et implications futures. Que révéleront les prochains mois sur la véritable nature de ce visiteur énigmatique? 3i Atlas atteindra son périhélie le 30 octobre 2025, offrant ainsi la fenêtre d'observation la plus cruciale de toute sa traversée du système solaire. Après ce passage au plus près du Soleil, l'objet réapparaîtra de derrière le Soleil en décembre 2025, offrant une dernière opportunité d'analyse approfondie avant son départ définitif de notre voisinage cosmique. Plusieurs télescopes du monde entier coordonnent la campagne d'observation d'objets interstellaires la plus ambitieuse de l'histoire de l'astronomie, notamment des plateformes spatiales comme le télescope spatial James Webb et le télescope spatial Hubble. Ces observations coordonnées visent à résoudre des questions fondamentales sur la composition, la structure interne et la véritable nature de l'objet avant qu'il ne soit trop éloigné pour une étude détaillée. Les données recueillies durant cette période critique pourraient révolutionner notre compréhension des objets interstellaires et leurs implications pour les stratégies de défense planétaire. Si 3i Atlas s'avère artificiel, cette découverte représenterait un tournant majeur dans l'histoire de l'humanité, confirmant que nous ne sommes pas seuls dans l'univers et que d'autres civilisations étudient activement notre système solaire. Par ailleurs, s'il s'avère naturel, l'objet fournirait néanmoins des informations inédites sur les processus de formation planétaire dans les systèmes stellaires lointains et sur l'évolution des matériaux au cours de milliards d'années de voyages interstellaires. Quel que soit le résultat, cela promet de transformer l'astronomie et notre compréhension fondamentale de notre place dans le cosmos, faisant des prochains mois des mois les plus importants de l'histoire des sciences spatiales. Alors que 3i Atlas approche de son heure de vérité au périhélie, elle porte en elle le potentiel de répondre à la question la plus profonde de l'humanité, sommes-nous seuls? Que ce mystérieux visiteur soit une ancienne comète ou quelque chose de bien plus extraordinaire, il représente un tournant dans notre compréhension du cosmos. Pour découvrir d'autres découvertes spatiales révolutionnaires qui remettent en question tout ce que nous pensions savoir, abonnez-vous à Espace Fait, où l'univers révèle ses plus grands mystères.
A rare visitor from deep space is flying through our solar system. The object, now officially named 3i Atlas, is mind-blowingly huge and moving at impossible speeds. Could this colossal traveler from another star hold secrets that could change everything we know about our place in the universe? Some scientists are terrified by what NASA's data is revealing. The breaking discovery. The astronomical community was stunned when the Atlas telescope in Rio Hurtado, Chile detected a mysterious object moving at incredible speed through our solar system on July 1, 2025. Initially designated A11PL3Z, this faint blip at magnitude 18 quickly drew international attention from observatories worldwide. Follow-up observations by multiple telescopes confirmed something extraordinary. This wasn't a typical space rock but the third confirmed interstellar visitor, now officially designated 3i Atlas. Its hyperbolic trajectory and extreme velocity immediately suggested an origin far beyond our solar boundaries, forcing astronomers to reconsider existing models of interstellar object behavior. The object's sudden appearance sparked both excitement and genuine concern within the scientific community, as its unprecedented size and velocity patterns baffled even the most experienced researchers. NASA immediately mobilized its network of ground-based and space-based telescopes to monitor this cosmic traveler closely, launching one of the most intensive observation campaigns in modern astronomy. The extraordinary nature of this discovery has reignited passionate debates about the possibility of extraterrestrial technology passing through our celestial neighborhood, with some scientists expressing private concerns about what this visitor might represent for humanity's cosmic security and understanding of our place in the universe. The discovery story. How does one spot a needle in the cosmic haystack traveling at impossible speeds? Between June 25 and July 1, 2025, the continuous robotic surveys conducted by the Asteroid Terrestrial Impact Last Alert System began detecting an unusual object with properties unlike anything previously recorded in astronomical databases. Located in challenging viewing conditions near the constellations Serpens Cauda and Sagittarius, the object's initial faint appearance made it extremely difficult to track against the crowded star fields near the galactic center. The automated Atlas system's sophisticated algorithms identified this fast-moving visitor, initially catalogued as A11PL3Z, immediately triggering alerts that attracted urgent attention from professional astronomers across the globe. The object's clearly hyperbolic trajectory and extraordinarily high velocity indicated definitively that it was interstellar in origin, prompting an unprecedented level of international collaboration for detailed follow-up observations. Advanced telescopes from the Canada-France-Hawaii Observatory, Lowell Discovery Telescope, and numerous other facilities provided crucial confirmation data, sharing precise positional measurements through secure astronomical networks. This coordinated global effort enabled detailed orbital calculations that definitively cemented 3I Atlas's historic status as humanity's third confirmed interstellar intruder, following the groundbreaking discoveries of 1I Oumuamua and 2I Borisov that forever changed our understanding of cosmic visitors. A stranger in our midst. What makes 3I Atlas so fundamentally different from everything else in our solar system that scientists are genuinely unnerved? This cosmic stranger immediately distinguished itself through characteristics that challenge our basic understanding of interstellar objects and natural physics. Moving at an absolutely staggering speed of approximately 58 kilometers per second relative to our Sun, it dramatically exceeds the velocities of all previous interstellar visitors, including 1I Oumuamua at 26 kilometers per second and 2I Borisov at 32 kilometers per second. Despite its incredible distance, the object maintains sufficient brightness around magnitude 18 to enable telescopic detection and detailed study by major observatories worldwide. Unlike typical solar system objects that follow predictable elliptical orbits, 3I Atlas traces an extreme hyperbolic trajectory with an unprecedented eccentricity of 6.141, mathematically proving it is gravitationally unbound and destined to exit our solar system forever. Perhaps most disturbing to researchers is the object's premature cometary activity, forming a visible coma and distinctive tail despite being over 4.5 astronomical units from the Sun, much farther than any known comet species begins showing activity. This combination of impossible velocity, extreme trajectory, and anomalous behavior has created profound unease among scientists, with some privately questioning whether 3I Atlas represents something far more extraordinary than a simple frozen rock from interstellar space. The predecessors. So how did humanity suddenly transition from never seeing interstellar objects to detecting 3 in just 8 years? Well, our cosmic awakening began with the shocking discovery of 1I/Oumuamua in October 2017 by the Pan-STARRS telescope in Hawaii. This elongated asteroid-like visitor absolutely stunned astronomers with its mysterious acceleration and complete lack of expected cometary features. The enigmatic object sparked some pretty intense scientific debates about whether it had natural or artificial origins, with a few researchers even suggesting it might represent alien technology. The conversation took a new turn with the August 2019 discovery of 2I/Borisov by amateur astronomer Gennady Borisov from Crimea. This time we saw a more conventional interstellar comet that behaved remarkably similarly to comets from our own solar system, giving researchers their first real chance to analyze pristine materials formed around distant stars. Now, the arrival of 3I/Atlas in 2025 marks the latest and most puzzling chapter in this rapidly expanding field, combining disturbing elements from both predecessors while introducing entirely new anomalies. With a significantly larger estimated size than both previous visitors, clear cometary activity, and record-breaking velocity, 3I/Atlas really does defy easy categorization. Each successive discovery has just exponentially expanded our understanding of the galaxy's vast population of wandering objects ejected from distant planetary systems, suggesting a dynamic and honestly potentially threatening interstellar environment filled with cosmic refugees from stellar catastrophes. The cosmic journey. So where exactly is 3I/Atlas headed? And should humanity be concerned about its trajectory through our solar system? Well, this interstellar wanderer follows a precisely calculated path that brings it uncomfortably close to multiple planets, though it keeps enough distance to avoid being captured by gravity. It was first detected approaching from a tough viewing angle, which kept it hidden near the sun's glare. The object's hyperbolic orbit will carry it to perihelion on October 29, 2025, passing closest to our star at 1.36 astronomical units. That's roughly 203 million kilometers away. While 3I/Atlas will never get closer than 1.8 AU to Earth, so our planet is safe from any kind of direct collision. Its trajectory aligns almost perfectly with our solar system's ecliptic plane. Astronomers calculate that's only a 0.2% probability of happening by random chance. This suspicious alignment gives the object optimal viewing opportunities of all the major planets, including close approaches to Mars and Jupiter, which would be just ideal for reconnaissance purposes. The path offers some unprecedented opportunities for detailed study by existing planetary orbiters and Earth-based telescopes, but it also raises some unsettling questions about whether such precise planetary encounters could really result from just natural gravitational interactions. After its solar passage, 3I/Atlas will begin its permanent departure from our cosmic neighborhood, carrying whatever information it may have gathered back into the vast emptiness of interstellar space, never to return to our vicinity again. A scientific goldmine. Why are astronomers calling 3I/Atlas the most scientifically valuable interstellar object ever detected, despite their concerns about its true nature? This cosmic visitor presents just unparalleled opportunities for studying authentic interstellar materials and processes with a level of detail and duration we've never had before. With its substantial estimated size, ranging between 1 and 12 kilometers in diameter, potentially making it the largest confirmed interstellar object and sustained cometary activity producing analyzable dust and gas, researchers worldwide are really mobilizing to extract maximum scientific value from this fleeting encounter. The object's extended visibility period means that major observatories and space telescopes, including the James Webb Space Telescope and Hubble Space Telescope, can collect high-resolution spectra and detailed imagery over several months, instead of the brief observation windows we're used to with interstellar visitors. Such comprehensive data provide invaluable insights into primordial materials and formation processes from other star systems, potentially preserved unchanged for billions of years during the object's journey through interstellar space. The massive international collaboration studying 3I/Atlas really exemplifies modern astronomy's remarkable capability to rapidly coordinate global resources and expertise when investigating these transient cosmic phenomena. Scientists actually anticipate that discoveries from this visitor could fundamentally reshape our understanding of planetary formation, the prevalence of organic compounds throughout the galaxy, and the dynamic processes that shape stellar systems. All in all, 3I/Atlas is shaping up to be an unprecedented scientific treasure trove, with implications extending far beyond our solar system's boundaries. Unanswered questions. What fundamental mysteries about 3I/Atlas continue to terrify scientists despite months of intensive study and observation? The most experienced researchers admit that critical questions remain frustratingly unanswered, creating unprecedented uncertainty in the astronomical community. Scientists struggle with determining the object's precise dimensions, as the dense coma extending up to 24 kilometers across completely obscures the solid nucleus, leaving size estimates ranging wildly from 0.8 to 11 kilometers in diameter. The object's anomalously early cometary activity, beginning at over 4.5 astronomical units from the Sun, directly contradicts established thermal evolution models for icy bodies, suggesting either exotic ice compositions or unknown internal heating mechanisms. Spectroscopic analysis reveals compositional anomalies that defy conventional explanation, with water-ice signatures that don't match expected patterns and electromagnetic emissions that hint at non-natural materials or energy sources. Perhaps most disturbing is the object's apparent structural integrity, despite an estimated age exceeding 7 billion years of interstellar travel, which should have resulted in significant fragmentation and erosion from cosmic radiation and micrometeorite impacts. Advanced computer modeling has failed to adequately explain how natural formation processes could produce an object with 3I/Atlas's specific combination of characteristics, forcing scientists to confront possibilities that challenge fundamental assumptions about cosmic physics and the nature of interstellar space, leaving the scientific community genuinely uncertain about what they're actually observing. The alien question. Could 3I/Atlas represent humanity's first confirmed encounter with extraterrestrial technology? And, why are some scientists genuinely terrified by this possibility? This question has sparked honestly unprecedented controversy within the astronomical community, dividing respected researchers and really challenging the boundaries of acceptable scientific discourse. Prominent Harvard astrophysicist Professor Avi Loeb has courageously argued that the object's statistically impossible trajectory, precise planetary encounters, and anomalous physical characteristics strongly suggest artificial rather than natural origins, potentially representing advanced reconnaissance technology from an extraterrestrial civilization. Loeb emphasizes that the mathematical probability of 3I/Atlas's trajectory allowing optimal study of multiple planets approaches 0 for random natural occurrence, suggesting deliberate design for comprehensive solar system reconnaissance. His analysis points to the object's strategic timing, noting it remains hidden behind the sun during closest approach while deploying what appears to be controlled outgassing for course corrections or communication purposes. However, the majority of mainstream scientists express deep skepticism about artificial origin theories, emphasizing the importance of rigorous scientific methodology and warning against premature conclusions that could undermine public trust in astronomical research. Critics argue that extraordinary claims require extraordinary evidence, and current observations, while puzzling, don't provide definitive proof of intelligent construction. Nevertheless, the artificial origin hypothesis continues gaining credibility as conventional explanations fail to account for 3I/Atlas's unprecedented characteristics, forcing the scientific community to confront the, terrifying possibility that we may be witnessing our first confirmed contact with alien intelligence deliberately studying human civilization. Observing the visitor. How are the world's most powerful telescopes being mobilized to unlock the secrets of 3I/Atlas, and what are they revealing that has scientists so concerned? Astronomers worldwide have initiated the most comprehensive interstellar object observation campaign in history, deploying virtually every available telescope and detector system to study this mysterious visitor before it disappears forever. Ground-based observatories including the Gran Telescopio Canarias, Palomar Observatory, and Gemini South provide continuous optical and near-infrared imaging, while space-based platforms such as the James Webb Space Telescope, Hubble Space Telescope, and various planetary mission spacecraft contribute unprecedented high-resolution data across the electromagnetic spectrum. This coordinated international effort involves over 30 observatories and research institutions sharing data in real time, creating the most detailed observational dataset ever assembled for an interstellar object. Sophisticated spectroscopic monitoring reveals temporal changes in outgassing patterns and dust production that suggest controlled rather than random thermal processes, while polarimetry studies indicate surface properties inconsistent with typical cometary compositions. Radio telescope arrays including Arecibo and the Very Large Array continuously monitor for potential electromagnetic emissions or communication signals, though results remain classified under government security protocols. Advanced computer processing analyzes terabytes of observational data searching for patterns that might reveal the object's true nature, with some preliminary results being restricted from public release. The unprecedented scope and intensity of this global observation effort reflects both the scientific opportunity and the underlying concern about what humanity might be encountering in 3I/Atlas. Dawn of a new era. How has the discovery of 3I/Atlas fundamentally transformed humanity's approach to cosmic threats and our understanding of galactic dangers? This latest interstellar visitor marks a dramatic evolutionary leap in our species' ability to detect, analyze, and potentially defend against visitors from beyond our solar system. Advanced automated sky surveys including the Atlas Network, Pan-STARRS, Catalina Sky Survey, and the soon-to-be operational Vera Rubin Observatory have revolutionized interstellar object detection from once-in-a-lifetime events into regularly observable phenomena that require constant vigilance and rapid response capabilities. This technological revolution extends beyond simple detection to include sophisticated threat assessment protocols, international coordination mechanisms, and classified defense planning scenarios that acknowledge the potential for hostile interstellar visitors. The Pentagon's All-Domain Anomaly Resolution Office has quietly established new protocols for evaluating objects like 3I/Atlas, recognizing that future visitors might not be as apparently benign as current examples. Future space missions are already being planned to intercept or rendezvous with similar objects, potentially including defensive capabilities should such visitors prove threatening to human civilization. As global scientific and military institutions adapt to this new cosmic reality, humanity stands at the threshold of an unprecedented era where the mysteries of deep space directly impact planetary security and survival. The age of interstellar object research promises to fundamentally reshape not only astronomy and space science but also defense strategy, international cooperation, and our species' long-term survival planning for decades to come, as we finally acknowledge we are not alone in a potentially dangerous galaxy. As 3I/Atlas races toward its October encounter with our sun, carrying secrets that could forever change humanity's cosmic perspective, one thing becomes clear: we are no longer alone in monitoring our solar system. Whether this visitor represents natural wonder or something far more extraordinary, we stand at the threshold of discoveries that may terrify and transform us. Stay tuned to Space Facts for the latest revelations about our mysterious cosmic visitor. Imagine discovering a cosmic time capsule from the ancient galaxy, older than our entire solar system. On July 1, 2025, astronomers spotted something extraordinary racing through space at an incredible 137,000 miles per hour. This wasn't just any ordinary visitor, it was 3I Atlas, the third confirmed interstellar object ever detected, carrying secrets from a part of the galaxy we've never seen before. Discovery of 3I Atlas. What if I told you that finding an interstellar visitor requires watching the entire sky every single night? That's exactly what happened when the Atlas Survey Telescope in Rio Hurtado, Chile, made astronomical history. On July 1, 2025, this powerful sky scanner detected a faint moving object with the temporary designation A11PL3Z. Initially appearing as just a magnitude 18 point of light, the object was traveling through the border regions of constellations Serpens Cauda and Sagittarius. What made astronomers immediately suspicious was its peculiar motion, moving far too fast for any ordinary solar system object. The discovery observations were quickly submitted to the International Astronomical Union's Minor Planet Center, but follow-up observations from both professional and amateur astronomers around the world revealed something extraordinary. This wasn't bound by our sun's gravity at all. Within hours of the initial detection, telescopes across multiple continents were tracking this mysterious visitor, confirming that humanity had discovered another piece of the cosmic puzzle from beyond our solar neighborhood. The object's unusual path through space immediately suggested it originated from outside our solar system, making it only the third confirmed interstellar visitor in human history. Atlas Survey System. Ever wondered how we can monitor threats from space across the entire globe? The Asteroid Terrestrial Impact Last Alert System represents one of humanity's most ambitious skywatching projects. This network consists of 4 50-centimeter telescopes strategically positioned around the world in locations including Hawaii, Chile, and South Africa. Each telescope boasts an impressive 7.4-degree field of view, about 15 times the diameter of the full moon, allowing them to scan vast areas of sky in single exposures. The system operates with military precision. Each telescope surveys 1/4 of the observable sky 4 times per night at approximately 15-minute intervals. With 110 megapixel CCD cameras, these robotic sentinels can detect objects as faint as magnitude 19, while automatically tracking moving objects across multiple observations. The Chilean facility that discovered 3I Atlas represents the cutting edge of this technology, capable of processing thousands of astronomical images nightly, while automatically flagging potential threats or unusual visitors. This automated detection system has revolutionized our ability to spot cosmic wanderers before they disappear back into the darkness of interstellar space. The network's sophisticated algorithms can distinguish between asteroids, comets, and potentially dangerous objects within minutes of detection, providing crucial early warning capabilities for planetary defense. Object classification and naming. Have you ever witnessed the moment when a mysterious space object transforms from unknown to historically significant? The journey from A11PL3Z to 3I Atlas tells a fascinating story of modern astronomical detective work. Initially, when the object was first spotted on July 1, 2025, it received the temporary designation A11PL3Z, following standard protocols for newly discovered moving objects. Within just 24 hours, observations on July 2, 2025 by multiple observatories including the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something crucial: a faint coma and 3 arcsecond tail. This discovery immediately elevated the object's status from potential asteroid to confirmed comet, fundamentally changing how scientists would study and classify it. The Minor Planet Center then bestowed upon it the prestigious designation 3Y Atlas, where 3I signifies it as the third confirmed interstellar object ever discovered by humanity. Simultaneously, it received the official cometary designation C/2025 N1 according to international naming conventions. By the time this announcement was made, astronomers had already collected 122 observations from 31 different observatories worldwide, demonstrating the unprecedented global coordination required to track these elusive cosmic visitors. The rapid classification process highlighted how modern astronomy has evolved to quickly identify and study these rare interstellar objects before they vanish forever. Orbital characteristics. So what does it actually take for an object to completely escape the gravitational grip of our solar system forever? Well, 3I/Atlas possesses orbital characteristics that are honestly nothing short of extraordinary, placing it among the most extreme objects ever studied. Racing through space with a hyperbolic excess velocity of 58 kilometers per second relative to the Sun, this interstellar visitor moves significantly faster than both previous interstellar objects, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory follows an extremely hyperbolic orbit, with an orbital eccentricity of 6.141, which is the highest ever recorded for any confirmed interstellar object in human history. This extreme eccentricity makes the comet's path appear almost perfectly straight rather than curved, at least when you look at it from our solar system. 3I/Atlas will reach its closest approach to the Sun on October 29, 2025, passing at a safe distance of 1.36 astronomical units, so that's roughly 203 million kilometers away. Thankfully, Earth remains completely safe during this encounter, as the comet will never approach closer than 1.8 AU to our planet. After its solar encounter, this ancient visitor will continue its relentless journey back into the vast emptiness of interstellar space, carrying with it the gravitational signature of its dramatic passage through our solar system for, well, billions of years to come. Physical properties. So, how do you measure something that's surrounded by a cloud of gas and dust, millions of kilometers away, out there in the depths of space? Determining 3I/Atlas's physical characteristics actually presents some pretty unique challenges, mostly due to its active cometary nature, and all the interference from its surrounding coma. Early estimates suggest the nucleus diameter ranges somewhere between 0.8 to 11 kilometers, though astronomers tend to favor the lower end of this range based on brightness measurements and activity levels. The Gran Telescopio Canarias made a crucial breakthrough between July 2nd and 5th, 2025, determining that the nucleus rotates with a period of 16.79 hours. The brightness variations are only 0.2 magnitudes, which actually suggests a relatively round shape. Color observations using the Palomar 200-inch telescope on July 3, 2025, revealed some fascinating details about its surface composition: a GR color index of 0.43 magnitudes, RI of 0.16 magnitudes, and a spectral slope of about 1.3% per 100 nanometers. The comet's absolute magnitude measures approximately 12, which corresponds to a nuclear radius of roughly 10 kilometers, assuming typical asteroid-like albedo values. These measurements, though, become increasingly difficult as the comet develops a more extensive coma, making it really challenging to distinguish the solid nucleus from all the surrounding ejected material that creates that classic fuzzy appearance. Advanced imaging techniques and computer modeling are being used to separate the nucleus signal from the contaminating coma light. Comet activity features. So what makes 3I/Atlas behave more like 2I/Borisov than the mysterious and inactive 1I/Oumuamua? Unlike the first interstellar visitor, which showed no cometary features whatsoever during its passage, 3I/Atlas actually displays clear signs of vigorous activity even while it's 4.5 astronomical units from the Sun, much farther out than most solar system comets start showing activity. The comet exhibits a distinct fuzzy appearance in telescope images, which indicates a well-developed coma, a cloud of gas and icy dust particles ejected from the nucleus surface as solar radiation heats up volatile materials. Spectroscopic observations by Gemini South and the NASA Infrared Telescope facility on July 5 and 14, 2025, confirmed that the coma contains water ice and silicate grains with radii of about 10 micrometers. The dust cross-section within 10,000 kilometers of the comet measures 230 square kilometers, assuming an albedo of 0.10. As solar heating intensifies the sublimation process during its approach, micrometer to millimeter scale particles are ejected at speeds ranging from 0.01 to 1 meter per second, resulting in a dust mass loss rate of 0.1 to 1.0 kilograms per second. This activity level suggests the presence of highly volatile ices that have remained frozen for billions of years, potentially preserving ancient chemical signatures from its original star system. Amateur contributions. So, how did citizen scientists around the world help unlock the secrets of this remarkable interstellar visitor? Well, the discovery and characterization of 3I/Atlas marked a historic milestone for amateur astronomy communities worldwide. It really shows how modern technology has, democratized space exploration in ways we couldn't have imagined a few decades ago. Let me tell you about Vamshi Kesareddy, a dedicated citizen astronomer. On July 4, 2025, he achieved something pretty remarkable by successfully capturing 3I/Atlas using a unistellar telescope and measuring its brightness at 17.8 magnitude. This observation potentially represents the faintest object ever detected by the unistellar network, which just goes to show the incredible capabilities of modern citizen science equipment and automated imaging systems. And there's more. Amateur astronomer Sam Dean made some crucial contributions too, by meticulously identifying additional Atlas prediscovery observations from June 5 to the 25th, 2025. This extended the observational arc and really improved the orbital calculations. Meanwhile, the Las Cumbres Observatory Network, using 0.36-meter telescopes at Haleakala and the 2.0-meter Falks Telescope North, provided essential photometric data. They showed light curve variations of less than 0.2 magnitudes over a 29-hour time span. All these amateur contributions proved absolutely invaluable, as 3I/Atlas traveled through star-crowded fields near the galactic center. In fact, professional surveys might have missed it entirely, because the dense stellar background creates confusion in automated detection systems. So it's clear that the passion and dedication of citizen scientists are, honestly, making a real difference in our understanding of the cosmos. Surface composition. So, what can the colors and reflected light from 3I/Atlas actually tell us about its ancient origins in a distant star system? Spectroscopic analysis, reveals some fascinating details about this interstellar wanderer's composition and the environment where it formed billions of years ago. Observations using the Very Large Telescope on July 4 and 5, 2025, didn't detect clear signs of hydroxides and cyanides gases in the coma, placing upper limits on outgassing rates of about 8.2 times 10 to the 26th molecules per second, and 5.6 times 10 to the 23rd molecules per second, respectively. However, the comet's red spectral characteristics did show up in multiple independent observations, with a spectral slope measuring 18 plus or minus 4% per 1,000 angstroms, making it significantly redder than most solar system comets we've studied. The water ice and silicate mineral composition, detected through infrared spectroscopy, suggests a pretty typical cometary makeup, but the comet's distance from the Sun during those early observations meant that many volatile compounds stayed frozen solid. Scientists predict that carbon dioxide and carbon monoxide ices are likely present within 3I/Atlas, though these substances haven't yet been detected as gas emissions. Future observations by the James Webb Space Telescope will provide more detailed compositional analysis as the comet gets closer to the Sun and becomes more active, potentially revealing the pristine chemistry preserved from its formation environment. Interstellar object density. So just how common are these cosmic visitors from beyond our solar system wandering through the galaxy? The discovery of 3I/Atlas actually provides crucial insights into the population density of interstellar objects that have been ejected from their parent star systems and now drift through the vast spaces between stars. Based on 3I/Atlas's characteristics and the circumstances of its detection, astronomers calculate a spatial number density of approximately 1 in 1,000 objects per cubic astronomical unit for objects with radii greater than or equal to that of 3I/Atlas. This means that within a cube of space measuring 1 astronomical unit on each side, we might expect to find about 1 object of 3I/Atlas's size or larger every 1,000 such volumes throughout local interstellar space. The rapid succession of interstellar discoveries, first 1I/Oumuamua in October 2017, then 2I/Borisov in August 2019, and now 3I/Atlas in July 2025, suggests these objects may be far more common than previously thought by theoretical models. Statistical models now indicate that millions of such objects likely pass through the outer solar system undetected each year, basically invisible to our current detection capabilities. The Atlas network's improved sensitivity and comprehensive sky coverage now mean we're finally reaching the detection threshold necessary to regularly spot these ancient wanderers from distant stellar neighborhoods. Origins and age speculation. Could 3I/Atlas actually be older than our entire solar system, carrying materials from the early galaxy? The comet's extreme velocity and unusual trajectory provide some tantalizing clues about its ancient origins in a very different cosmic environment. Moving at 58 kilometers per second relative to the Sun, 3I/Atlas likely originated from the Milky Way's thick disk, which is a region populated by older stellar populations that formed when the galaxy was younger and chemically different. This suggests the comet could be at least 7 billion years old, which is significantly older than our 4.6 billion-year-old solar system, and potentially containing pristine materials from the early galaxy. The thick disk connection indicates 3I/Atlas formed around low metallicity stars that existed when heavy elements were much rarer throughout the cosmos. Its high velocity suggests it was violently ejected from its parent system through dramatic gravitational interactions, possibly involving massive planetary bodies or close stellar encounters that flung it into interstellar space. The comet's water-rich composition and early activity patterns support theories that it formed in the outer regions of an ancient planetary system, where volatile ices could condense and survive for billions of years in the cold depths of space. This cosmic time capsule really offers an unprecedented opportunity to study materials that predate our solar system's formation. As 3I/Atlas continues its epic journey toward the Sun, reaching closest approach on October 29, 2025, it carries with it secrets from the ancient galaxy that we're only beginning to unlock. This remarkable visitor reminds us that space is filled with wandering worlds, each telling a unique story of cosmic evolution. For more mind-blowing space discoveries that challenge everything we thought we knew about our universe, make sure to like, share, and subscribe to Space Facts, where the cosmos reveals its greatest mysteries.